Hi guys. Like in many interviews are asking about what is the lazy evaluation. Let's come to like what is the lazy evaluation, why we need to use the lazy evaluation. Let's discuss about lazy evaluation. Lazy evaluation means lazy evaluation means the execution will not start until an action is triggered. Okay, the transformations are in lazy nature. Suppose when we call some like operations on RDD, it does not execute immediately. Spark adds them to a dag of like a computation, and only when driver requests some data, this DAG actually gets executed. For like what is the mainly disadvantage, like advantages of lazy evaluation, it's an optimization techniques. Like it provides optimizations by reducing the number of queries. That is the one of the advantages. And second, it save the around trips between the driver and cluster, like thus speed up the process. Let's come to some scenarios, and you can see, right, in Spark transformations or lazy operations means that none of the transformations get executed until you will call an actions on PySpark RDD. Okay, PySpark RDD. That means like since the RDD are immutable, any transformations on it results in a new RDD, leaving the current one unchanged. Let's discuss about one example. Like if you want to buy certain items from any specific nearby your store, you want to collect from your family side, like what are all items we need to buy. Those items you need to those list of items you need to list of items to be purchased. Okay, need to be purchased, and then you need to write it a small piece of paper to make all arrangements to reach out the shop. Until then, only when you reach the shop, we do nothing until that. Okay, let's come to a scenario one. Okay, let's consider let's consider let's consider when spark is not spark when spark is not lazy. Okay, when spark is not lazy, let's discuss about this one. Like come to know, like for example, okay, we can do RDD 1 equal to from cluster in the sense that is called HDFS. Okay, whatever it what like you can do, right? For example, we having 1 GB of file, 1 GB file loaded into memory from the HDFS. Okay, we are having the transformations like this one, like this RDD equal to load data from the cluster, and coming to like RDD 1 dot print of line 1. Print of line 1, what it does exactly, right? Suppose in case of when you in case of when the first line executed entry would be made to be the DAG, and the first like 1 GB of file would be loaded into memory. Okay, in the second line, like second line is the second line is a very like a disaster, that just to be print the line of line of the file. Okay, line of the whichever file we are loaded into HDFS memory, right? Those in that entire file, it's printing the it's print the like line 1 of the file, the entire 1 GB file loaded into memory. This is the one case. Okay, coming to second case, consider as um, consider when Spark is lazy. When Spark is lazy. Okay, let's talk about scenario 2. Same like we can take RDD1 equal to load data from cluster in the sense HDFS, and again we are printing here RDD1 dot print line 1. Like line 1 in this case, first line executed an entry is made to be a DAG. Okay, entire execution plan is built here. Okay, entire plan execution is built here. Okay, as Spark does an internal operation like optimization. Instead of loading entire here entire instead of loading entire 1 GB of file, right? Here we can do instead of like entire 1 GB of file, entire 1 GB of file, only first line of the file loaded into this memory. Okay, then we can print the only first line of the entire the file. Okay, you understand, right? Let's talk about some transformations here. The following list of common transformations supported by Spark. Okay, map and filter, and then flat map, or some few of the here actions as well. Map partitions. Okay, these are all the transformations. These are all the transformations actions here. Let's talk about a few example on next video. Okay, thanks guys. Thank you so much for all watching this video.